In the mobile ad hoc network, the nodes are connected without infrastructure. In the MANET, while the data transmit or receive between the nodes, the energy consumption was main issue because it have a limit battery power. Ad hoc on-demand multipath distance vector routing protocol energy consumption optimization via fitness function. By the AOMDV protocol, we get all the possible routes from the source to destination node. The suggested techniques uses the fitness function of AOMDV. The fitness function is primarily used to reduce energy consumption in multipath routing by determining the best route from source node to destination node. The FF AOMDV protocol performance has been evaluated using Network Simulator version 2 and compared to that of AOMDV protocol with optimized link state routing OLSR. This session details how well the implemented AOMDV-FF protocol performs. The suggested protocol's performance is constructed with that of current approaches. This is a list of the different parameters that were utilized for the suggested simulation. To be able to transmit data wirelessly from source node to destination node in a mobile ad hoc network, certain characteristics must be recorded in order to evaluate. The following figure shows the packetized transmission of data from source to destination. Several nodes can be seen to be participating in this data transmission process. The research uses a network coding technique that allows us to transport data without suffering any data loss. In order to access the proposed model in terms of the following evaluation criteria, the simulation and proposed model will be used. The packet delivery ratio of the ACD shown in this. This time plotted on the y-axis and PDR is plotted on x-axis. The ratio of total packets sent from source nodes to destination nodes are the actually delivered is known as the packet delivery ratio and its network metric. In the ACD, the PDR value is quite close to 1. This is the greedy forwarding packet delivery ratio. The graph has time on the y-axis and PDR on the x-axis. To provide the shortest routing path in greedy, routing optimization is used. The PDR value in this technique is around 1. This QoS packet delivery ratio is shown in this. Time is on the y-axis of the graph and PDR is on the x-axis. The packet delivery ratio that in the DSR protocol generated is used in this manner. This routing gives the network's dynamic router rather than the quickest path. This approach generates PDR value about 1, but it cannot give the shortest path. The energy usage of greedy forwarding. The graph shows time on the x-axis and average energy on y-axis. One of those tactics will be demonstrated to be the most efficient way to consume energy in MANET with the aid of AOMDV-FF. The energy consumed by this technique should be less than compared to the remaining techniques, and it's also produced the shortest path between source and destination. The energy usage for QoS. The graph has time on the x-axis and average energy on the y-axis. With the aid of DSR, one of those methods will be less effective method on energy use in MANET. This procedure should use more energy than the other techniques combined. It generates the dynamic routes than the quickest path.